Okay, welcome back, students. 8.2, trigonometric or polar form of complex numbers. So the rectangular form of a complex number is x minus yi. So this is rectangular form, okay? In the previous section, we used a and b as our variables. You could use a or b or x and y. Doesn't really matter. X and y in this case makes a little bit more sense because we're going to be changing it from, you know, we're using trigonometric, and x refers to the x value on the x-axis, and the y refers to the y value on the imaginary axis, the real axis and the imaginary axis. Okay. Relationships among x, y, r, and theta. X is equal to r cosine theta. Okay, so r is the magnitude of the hypotenuse there. Okay, and then cosine theta, that's going to be give me my x value. Okay, y equals r sine theta, and that's going to give me my y value. R is equal to x squared plus y squared. That's just the distance formula. Okay, think of this as a point. This over here as a point x comma y. Okay, in real, on the real axis for x, and the imaginary axis for y. Okay. Okay, and then tangent of theta is y over x. So that's how we would get angle theta. To figure out angle theta, you're going to do y over x, or theta is going to be inverse tangent of y over x. Given the fact that this could have more than one answer, depending upon what x and y are and what quadrant they live in. So we just need to make sure that we know which quadrant x and y are from. Are they from quadrant 1? Are they from quadrant 3? Are they? Because that's going to tell me what my angle is. Okay, on the circle. Okay, the complex plane. Plot the complex numbers. Again, we have a real axis and we have an imaginary axis. Okay, so 2 plus 3i. What's 2 plus 3i going to look like? Okay, well, 1, 2 in the real, 3 in the imaginary. So up 3, okay, positive, positive, right? So this is positive imaginary, negative imaginary, positive real, negative real. So over 2 in the real and up 3 in the imaginary is going to be right here. And so I'm going to plot that number 2, 3 in the imaginary real and imaginary plane there. Okay, what about negative 4 plus 2i? Negative 4 plus 2i. Well, negative 4, 1, 2, 3, 4, and then up 2. Okay, so this is 4, 2, and the 4 real, 2 imaginary. Now, what would happen if I wanted to add these two numbers together? Well, a couple of things. One, we could represent these imaginary values as vectors, okay, originating from the origin. And the fact that they're tail to tail means that I could create a parallelogram create a parallelogram here. Okay, and the resulting diagonal should give me the where that resulting vector is. Okay, so now let's find out exactly where that resulting vector is located. Let's add the real components together and add the imaginary components together. So 2 plus negative 4, that's negative 2, and 3 and 2, that's 5. So this is negative 2 and 5i. So this is going to be negative 2, and then 1, 2, 3, 4, 5, up 5. So this is negative 2, 5. Okay. Negative 2. Maybe my parallelogram's off a little bit. Right. the idea here. So I'm going to put my resultant vector in black there. Okay, so negative 2, 5. We added the two vectors together. We did it algebraically and we did it graphically. Okay, the trigonometric form of a complex number x plus yi is r cosine theta plus I sine theta. Okay, y plus I is r cosine theta. Remember, what was x? X was r cosine theta. And what was y? Y was r sine theta. And so if we factor out the r, right, because if this was x plus y I, then this would be r cosine theta, r sine theta I times I. And then if we factor out the r, we get r cosine theta plus I sine theta. Okay, factor out the r. Okay, and sometimes this is written as r CIS, or cosine I sine, r CIS theta, okay, as shorthand. Okay, so we have an r and we have a theta, and that tells me, okay, exactly where a point is located in two space. So if I have a theta, an angle, and then I have a radius r, that tells me exactly where a point is located in space. For example, if I wanted this point over here, just a random point, well, how would I get that point? Well, it would be from 0, 0, I'd have a vector going out to that point. Okay, and the length of this vector is r, and I would have an angle theta starting from the x-axis, the positive x-axis, I would have an angle theta. And so any point in two space can be referred to in terms of r and theta. Go out a certain amount, okay, from the origin to hit your point, and then your angle theta is going to dictate, you know, where on that circle you're gonna end up. Okay, so the angle and the radius do dictate where any point is on a two-dimensional graph. Okay, also written RCIS for shorthand. Okay, R is the absolute modulus of x plus yi, okay, or the magnitude, and theta is called the argument. So modulus argument. Okay, convert each between rectangular and trigonometric forms. So 10 cosine 135 plus I sine 135, that's okay, that's the trigonometric form. I want to change this to rectangular form. So I want to get x and y. So how would I get x and y? Yeah, x is r cosine theta and y is r sine theta. Okay. So yeah, r in this case is 10 cosine of 135, okay, is x. Y is 10 sine 135, okay. Well, cosine 135, that's in the second quadrant, and my reference angle is 45 degrees. So this is going to be x is equal to 10 times the cosine of 135. Now, cosines are negative in the second quadrant, which is where 135 lives. And so this is going to be negative radical 2 over 2. The sine, that's the y values, those are positive. Okay, positive in the second quadrant. So y is going to be 10 times radical 2 over 2. So this is going to be x is equal to, cancel that out, that's 5, negative 5 radical 2, and y is going to be equal to 5 radical 2. And so we have x plus iy. Okay, iy is going to be negative 5 radical 2 plus 5i radical 2. Okay, so that's that one. We converted it. Okay, what about the next one here? 8 minus 8i. Okay, this is written in Rectangular form, we want it in polar form or trigonometric form. Okay, so we need to find a couple of things. We need to find out what r is, and we need to find out what theta is. Okay, what's r and what's theta? Okay, so r in this case is going to be the square root of x squared plus y squared. Okay, now what is x and y here? Well, x is 8. And what's y? Y is negative 8. Okay, so r is going to be equal to, this is going to be the square root of 64 plus 64. Okay, notice that I have two 64s there. That's going to be the square root of 128. But I could have broken this down into basically 2 times square root of 64. Sorry, 2 times 64 radical, which is going to be radical 2 times radical 64, which is going to be 8 radical 2. Okay, so that's r. Okay, so r is 8 radical 2. Okay, what about theta? What about theta? What's theta going to be? Well, theta is going to be, let me move this over a little bit. Theta is going to be the inverse tangent of y over x. Okay, so theta is equal to the inverse tangent of y. What's y again? Y is negative 8 over 8. So that's the inverse tangent of negative 1. Okay, so what angle gives me the inverse tangent of negative 1? Yeah, it's actually negative 45 degrees is what I would get if I plug that into a calculator. However, what do we know here? Well, we know that the x, we have to check, the x is positive and the y is negative. Where is the x positive and the y negative on the unit circle, okay, or in my quadrants? Well, this is quadrant 4. And does negative 45 live in quadrant 4? Yes, it does. So I can leave it as negative 45 if I want, or I could add 360 to that and make theta equal to 315 degrees. Okay, so again, this does live in quadrant 4. So we're good. It checks out. Okay, it lives in quadrant 4. Okay, so now what's my trigonometric form here going to be? Well, this is going to be 8 radical 2 times the cosine of 315 degrees plus I sine of 315 degrees. Maybe I can move this over a little bit. I want to save enough room for the last problem here. Oops. There we go. Okay, so that is trigonometric form. Okay, negative 15. Negative 15 is just a real value. So there is no imaginary component here. So if I were to look at a graph of negative 15, where is negative 15 located? Well, it's way over here on the x-axis, negative 15. So what angle is that going to be from the positive x-axis? Well, that's 180 degrees. Okay, it's 180 degrees. So theta here is 180 degrees. What's r? Well, what's the distance between 0 and negative 15? What's the positive distance between 0 and negative 15? Well, it's 15. So in this case, r is equal to 15 and theta is equal to 180 degrees. Now, if you didn't know that, okay, if you couldn't figure it out or you didn't think about using the graph to get that, okay, to get this this angle and this distance. Okay, you can still do it using 0 as your imaginary component. Okay, so we could say, well, this is going to be negative 15 plus 0i, right? So if I were to say, well, what's r of r? R is going to be equal to the square root of negative 15 squared plus 0 squared. And all that's going to do is turn this negative 15 into a positive 225. And then I'm going to square root that. And that's going to go back to 15. So r is 15 here. Now, what about the tangent? If we take the inverse tangent of y over x, y is 0 in this case, and 0 over anything is just 0. So this really becomes the inverse tangent. Theta is equal to the inverse tangent of y over x, which is 0 over negative 15. So the inverse tangent of 0, okay, the inverse tangent of 0, you're just going to get 0 on your calculator if you plug that in. Okay, however, this 0 means that the angle would be 0 and it would live in the first quadrant. And it doesn't live in the first quadrant. It lives in the, I guess it's not in a quadrant, but it lives on the positive x-axis. In this case, it lives on the negative x-axis, which means we would have to add 180 to this to get to quadrant 2, or right in between quadrants 2 and 3. And so the theta here is 180. Okay, so that's 180. And so I can say this is r times, or 15 times, the cosine of 180 plus I sine 180. Okay, and the cosine of 180 is negative 1, which will give us a negative 15. The cosine of sine of 180 is 0, which will give us 0. So when we multiply this out, it should give us that negative 15 that we started with. Okay. Okay, 7, cosine of 205, I sine 205. Now these I'm going to have to do on the calculator. 205 is in kind of irregular value. So I'm going to say x is equal to 7 cosine 205. And y is equal to sine 205. R, this should be 7, sorry, 7 sine 205. Agree. So I'm going to go to the calculator on this one. Okay, make sure I am in the correct mode. I'm not. I need to go to degree mode. Okay, second quit. Okay, and I want to go 7 times the cosine of 205, and that's negative 6.34, roughly. So this is, x is approximately negative 6.34. Makes sense it's negative because where's 205 located? Where's 205 is located in the third quadrant. Okay, so the x should be negative and the y should be negative because it's third quadrant. Let me rewrite this. Sine 205 degrees. Okay. Now, what about the y value? Y is approximately what? Let's do the sine. So this is 7 sine of 205 is negative 2.96, I would say. Okay, negative 2.96. So what's my rectangular form? So this was trigonometric, or what we call polar form. Okay, it's really trigonometric form. Okay, what about rectangular form? How's that going to become rectangular form? Well, rectangular form is just x plus yi, right? Okay, so this is just going to be negative 6.34 plus, or we're going to be adding a negative here, so negative 2.96 times I. So I'm just going to write this as negative 6.34 minus 2.96 I. Approximately that. Okay, what about the last one here? Last one, we need to find an r and a theta. So let's work on that. The r we know is going to be the square root of x squared plus y squared. The theta we know is going to be the inverse tangent of y over x. Okay, so r is going to be the square root of -7 squared plus 2 squared. So r is equal to 49 plus 4, which is the square root of 53. Okay, so that's my r. R is square root of 53. R squared. What about theta here? Theta is going to be approximately the inverse tangent of 2, the y value, over the x value. 2 over -7. Okay. So theta, okay, is going to be approximately what when I plug in my calculator? Okay. So I'm going to go inverse tangent of 2 divided by -7. And it gives me a -15.94, I'd say 95 degrees. Okay, -15.94 or 95 degrees. Okay. So what that is in the fourth quadrant. -15.95 degrees, which is in the fourth quadrant. Okay, quadrant 4 here. However, where does my point live? My point lives where the x values are negative and the y values are positive. Where does that live? My point is not from the fourth quadrant or this -15. My point lives in the second quadrant, or exactly 180 degrees away from the value that I was given. Okay, it lives in the second quadrant. Okay, at -7, 2, not at 2 at 7, -2. So this would be 7, -2 over here. Okay, at -7, 2 is where I want it to be. The calculator gave me it living at 7, -2 because of the domain, I mean the range of inverse tangent. Remember, the inverse tangent can only give me values in quadrants 1 and 4. But I need a point that lives in quadrant 2. So what I'm going to do is I'm going to add 180 degrees to this. Okay, to get the next cycle. Okay, of tangent, right? Of the tangent value. So 180 plus this, we already have it stored into our calculator. So let's add 180, and I get 164.05. Okay, and so 164.05 degrees is theta. So we have that as theta. And so we're going to say that this is going to be square root of 53 times the cosine of 164.05 degrees plus I times the sine of 164.05 degrees. Okay, and that's section 8.2, and I will see you in the next section.